light emitting diodes. What are LEDs, as they are commonly referred to? Well, an LED is a electroluminescence electronic, you could say. It is an electronic that converts electrical energy into light energy. And it is made with a diode that can emit light. So basically how LEDs work, it's kind of simple. So a diode, you have a P and N junction. So a P junction has a whole bunch of protons or less electrons, so they have holes in it, which makes it more positive. And an N junction has a whole bunch of electrons, which makes it more negative. So this side, we have the N junction, and this side we have the P junction divided in the middle. So when electricity comes from the N junction and it flows into the P junction, the electrons fit into the holes and release energy in the forms of a photon. But when the energy or electrical energy comes from the P junction to the N junction, it pulls the electrons to the side and no energy can flow between, and that's how it works as a diode. And LEDs are made with gallium arsenide, gallium phosphide, and gallium nitride. But let's look at gallium arsenide and see how that works with LEDs. So gallium arsenide has a direct band gap. So the band gap between the conduction band and the valence electron band is direct, and it doesn't change the momentum of the electron. So when an electron goes from the conduction band to the valence band, which is higher energy, or when it goes from higher energy to lower energy, it has to release a photon in order to give off that energy, which is a photon in the visible light spectrum that we can see. And we can also make LEDs that work with infrared and other types of light on the light scale, you could say. And then the different distances between the energy gap or the energy band gap will produce different colors of light also. And in order to control the brightness of LEDs, you can either A, control the voltage levels, which will determine how much energy is being put into the LED, or you can use PWM signals, which stands for pulse width module signals. And pulse width module pretty much flickers the light on and off at a very rapid pace, so it gives the illusion that the light is actually less bright than it actually is. So let's look at different types of addressable LEDs. So what is an addressable LED? That pretty much means that a microcontroller can tell a certain LED on an LED strip what color it has to be, and that color can be different from all the other LEDs on the strip. So conventional LED strips is pretty much ground, red, green, blue, and if the 12 volts is hooked up to the red, the whole LED strip's gonna be red. But addressable, we can address each LED a certain color. So we're going to talk about 5 different types of addressable LEDs, and the first one is WS2812B and SK6812. So these operate between 3.5 and 5.3 volts. It uses a single wire for communication, which can cause some bugs, but it does offer 256 brightness levels with a 24-bit color and 8-channel PMW signal. So these are quite useful with low voltages and doesn't need to be that bright appliances. Then we have APA 102, a little bit higher voltage with 12.5 to 7.2 volts. Uses 2-wire communication, so a little bit more reliable, still 800 kilobits per second. And then a 24-bit color with an 8-channel PMW signal, like the last 2 addressable LEDs, but we only have 32 brightness levels. And this one is not as common, in at least my opinion. And the one that I use in my room is the WS2815. So it uses 12 volts, so we can get relatively bright, it has a backup data line. So if one of the LEDs on the strip fails, all the LEDs after it will still work because the data can still reach them. It's just that LED just broke. And this one's very easy to use with Arduino and Raspberry Pi. And the last LED we're going to talk about is LPD6803. So it uses 12 volts likewise, but it offers a much higher refresh rate and more precise color control. So if you need to make something that needs to refresh really fast or needs to be a certain color, I guess like text messages or something, you probably should use this LED strip. But the one that I used and most commonly is used is the WS2815. And let's take a look at how we code this and take a look at some of the effects that I've made with it. This is the code for the LEDs right here. So let's get right into it. So first we gotta include fast LEDs. How do we do this? Easy. Go to Sketch, go to Include Library, Manage Libraries, or you can just press this button right here. Type in fast LED, first one right here, and you see I already installed it. That's the one you want. Now that we got it, we close this out, and then boom, got that there. So then second, we're gonna define how many LEDs are controlled by a single chip. Second, we're gonna define what pin we want the Arduino to communicate with the LEDs with, which is pin 4, right here. And then we're going to define how many LEDs we have. And in this case, for my bed, we have 45 LEDs, or 46, 43. In this case, for my bed, we have 43 LEDs. And then we're going to make this, which is hue, and we're gonna make it 0. And this is going to control the hue of the LEDs, and we can pick which color we want it to be so we can get that rainbow effect. And we use this here because it's the same as a byte. It's just a different way to write the word. It's unsigned integer in the form of 8 bits, which is a byte. And then we put the number of LEDs, we just put it as a different function so we can just recall to it at different times. This is the setup, so we're gonna serial print so we can do any debugging, and then we're gonna tell the fast LEDs, which is this, a WS2812, and it's in the order of green, red, blue. So we're just defining all of this, and then for the loop is very simple to show it. So we have this little for loop for how many LEDs we have. We give each LED a different hue, and we add it from the hue plus whatever the LED we're on times 10, so they each have a different color in increments of 10 times what the other one is. And then every 25 milliseconds we're gonna add +1 to the hue, so it looks like it's changing. And then we're gonna show what the LEDs look like. So without this right here, the lights wouldn't light up. This function right here will show the current state of the LEDs. So we need this here at all times. And that's basically how this works. So right here, as you can see, this is not green, blue, red. This is hue, saturation, value. Value is brightness, saturation is how rich the color is, and then hue is what color is it. So it's just an easier way to make the rainbow effect without defining the red value, the green value, and the blue value. Okay, so this is the last one that I'm gonna do. If y'all want more explanations of the other LED effects, just let me know. But this one, basic stuff, going to define it all. And then same thing right here, just defining more. So this is the fire one. So we have to make a color gradient. So since RGB has more colors than are in a fire, we have to almost redefine what are the possible colors that it can have. So if the value is exactly 0, the color will be a dark red. If it's exactly 64, it will be red with a hint of green in it, so like an orange red. And then if it's 128, it's gonna be the brightest red it could possibly be. and then so on and so on. But if the number is like, let's just say 30, so it's kind of in between 0 and 64, it's going to have a blend of between these two. So it's going to be like somewhere in the middle of it. So since all these colors are red dominant, it's going to give it a more fire-like effect. So right here, we're just defining fire. That's fire, so it's a little bit easier for the computer to comprehend. And then likewise, we're just setting all this up. We're defining random numbers. So they all start out with a random, I guess, fire color to begin with. And then we go to the void loop. So for the number of LEDs, we're going to give it a palette color. So very, very basic. And then every 5 milliseconds, which is really, really quick, we're going to increase the palette color by 1. So it gradually moves between the palette colors. And then we're just going to show the LED. And that's pretty much how it works. So I guess let's go back to the palette so I can define it a little better. So this is the value. So the value is this, it's going to be this, and this is red, green, blue. So this is the actual color, and this is the value that this is determines the blending between the palettes.